We're going to solve systems of linear equations. A system of linear equations is a set of two or more linear equations used to solve a problem. Here is an example of a system. 10x plus 4y equals 100. 3x plus y equals 15. Solving systems of linear equations. To solve a system of linear equations is to find the point that the two lines intersect. Here is an actual example. This pay comparison chart. This graph shows two possibilities for Samantha. She could take a job at Tom's Shoes and get paid $15 an hour, while Satine Shoes pay $10 an hour, but a weekly commission of $100. So we can see the two equations here. The blue line is Tom's Shoes, represented by y equals 15x, or $15 per hour. And Satine's is the red line, represented by 10x plus the $100 commission, where x, again, is the number of hours worked, where y is the weekly salary. We're going to solve a system using graphing. Here's an example of what a system equation looks like. It's two equations with two variables, and we're going to use them together. So to solve the system of linear equations by graphing, you must graph the two lines in the system onto the same coordinate grid. At that point, you can find visually where they intersect. A solution to a system of equations is actually a coordinate point, x, y. Let's go back to our application sample. Here again is our pay comparison. In this example, the pay would have been the same at 20 hours per week. She would make $300. As we can see here, this is where the intersecting point is. It's up from 20 hours a week and over from $300 for her pay. We can write this answer as a coordinate point of 20, 300. Again, here are the two examples, the two equations for this example. Let's graph the following system of equations. Note that whether you graph using the table of point method, the x and y intercept method, or rewrite the equation into slope-intercept form and use those to graph, it doesn't matter at this point. You get to choose your method of graphing the equation of the line. I'm going to start with x plus y equals 8, and I am going to go ahead and use the intercept method. So as you can see, I have put in 0 for my x, so I'm left with y equals 8, so that is my y-intercept. The x plus 0, I've put 0 in for y, so my x-intercept is 8. So graphing that line looks like this. The next set, I'm going to do intercepts again with the second equation here, x minus 2y equals negative 10. So plugging 0 in for x, I have 0 minus 2y equals negative 10, which brings us down to negative 2y equals negative 10, or y equals 5. So the y-intercept is 5. For the y being 0, I plug that in, and I can see x plus 2 times 0 equals negative 10. Well, we know that 2 times 0 is 0, so x equals negative 10. So now I have graphed the second equation, x minus 2y equals negative 10. So the solution to this system of equation is where the two lines intersect, which is going to be at the point 2, 6. And that is my solution.